It's time. Now you know. All right, welcome everybody. This is the EMU session at IETF 122. We'll get through the administrivia and then go on to our presentations. I have all of the decks, so I think we're good. All right, so please note well, and this is a reminder of the IETF policies, the general policies here. But by participating in the IETF, you agree to follow these processes and policies. And more information is in a whole bunch of links that if you actually have the slides, you can read. All right, we'd like you to note really well that in the very basic essence, you should be nice to one another, no harassment. But if you believe you're being harassed or see somebody else being harassed, please check with the ombudsperson's team. All right, if you're here on site, we do have an on-site tool. Looks kind of like a telephone with an arrow coming out of it. If you are off-site, you probably want the full client with video. But if you're here on site, make sure you can scan the QR code and that'll get you connected. And we use that for participation recording as well. All right, general resources here. I think that's true of any of the meetings. And this is what our agenda looks like. We have a 90-minute slot. I'm currently showing 80 minutes occupied. We'll see how much of that actually ends up being used. Yeah. Should we jump into it? All right, Alan, are you mouth empty? All right, so.
Hello, mic works. Okay.
You can pass the control to the clicker.
Yeah, 7170 biz. I think we've been here before, but not quite in the same situation. Next slide. Oh, I have a clicker. I have the authority. So there are pending reviews. I had updated the document a couple of times since Dublin. The results of the interop testing are up on the wiki. Thanks to Cisco, Aruba, and Alex Clowder for doing some testing along with Union Molinen. So TEEP doesn't work, or at least it doesn't work the way it's documented. Everyone's agreed on EAP MS Chat v2 and EAP MS Chat v2 followed by EAP MS Chat v2. That works for all combinations of servers and supplicants. It looks like everyone did one thing, and that's that. So minor good news. After a minor fix in one server implementation, EAP TLS in the inner method works along with TLS followed by MS Chat v2. The issue is the EMSK compound MAC derivation. It looks like all of the servers tested with Microsoft, which does not do the EMSK compound MAC derivation. And as a result, all the servers did different things and didn't notice. So Microsoft implements TEEP, doesn't send the EMSK in the crypto binding. If received, ignores it, which is arguably wrong, but whatever. And all the server implementations are compatible with this behavior. And the various versions of WPA supplicant are compatible with this behavior. Compatible with the servers. So for Microsoft, EAP TLS works both for user and machine. EAP MS Chat works both for user and machine. They work in any combination. Basic password is not supported, and the PKCS7, PKCS10 attributes are not supported. I don't have a slide on the other implementations, but WPA supplicant supports basic password. It supports any inner EAP method. I believe Aruba and Cisco on the server side support only EAP TLS and MS Chat v2 free radius supports anything in the inner method, or any EAP method in the inner method, and basic passwords. So what do? We have multiple implementations which are shipping, which sort of interoperate, but perhaps in some situations don't interoperate. I think the recommendation is we don't break shipping product. We don't declare your product incompatible and invalid. So the proposal is we declare the Microsoft behavior TEAP v1. Everyone works with that. It's sort of fine. We then can publish 7170biz after stripping out all the EMSK stuff and replacing it with a note of to be determined in the future. After that, we decide what we want to do with the EMSK, compound MAC derivations. We do this thing called testing before we ship product. And then we define TEAP v2. And maybe we do other things with TEAP v2. I mean, there may be an opportunity here then also to say that, hey, if nobody does the PKCS7 attributes, PKCS10, we just strip that out of TEAP v1 and put that into TEAP v2. And given time frame, et cetera, there may be an opportunity to say that those attributes are required to be supported in TEAP v2, depending. They're there in theory. Nobody does anything with them. I would hope that we're not in the same situation as the MSK stuff with those crypto binding attributes, right? They're defined, but if nobody uses them, they may or may not work. It would be much better to be able to say that, yes, they're not only defined, they're implemented, and people have done things with them on multiple supplicants and servers. So if we define the crypto binding to only contain the MSK compound MAC, the EMSK compound MAC is always 0, we lose the crypto binding for EAP TLS inner methods. So you can terminate a TLS session, forward the inner data somewhere else, and arguably nobody knows. Or what we do is we say TEAP v1 can use EAP TLS, but only if it's the first method, and then the EMSK derivation isn't an issue because any of the complexities around it are not a problem. So yeah, as I said, PKCS 7, 10 issues. There are perhaps issues with chained methods. So Microsoft, for example, if the client is configured to do TLS for machine and MS chat for user, and the server asks for something else, Microsoft just replies with what it has. Or if it only has user authentication and you ask for machine authentication on the server, it just hands you the user authentication and goes, I don't know. I mean, so there's opportunity there for a bit more negotiation. Arguably, I would say this is probably the wrong behavior. I ask you for something and you hand me something else, right? You're broken. You should tell me, no, I'm sorry, I don't have that, or you should do it. Option 3 should not exist. So this is on the list of things we'll probably have to address in TEAP v2. I've had some off-list discussions with Uni Malinin about it. His opinion was that it's up to the server because the server's the one doing the authentication. The client does, to a certain extent, whatever it wants. And then the server decides, hey, I want to do 2 kinds of authentication, but the client only supplied 1. That may be okay, right? That may be a policy decision to then put the device into some kind of captive VLAN. So all of these issues have to be explained in the document in excruciating detail, because I hate implementing protocols where the middle goes and then a miracle occurs, or here be dragons. So where do we go from here? Does this make sense? Do people agree? Do we want to burn TEAP with a fire?
Yeah. So Joe Sellaway speaking as a participant. Yeah, I mean, removing the things that don't work, that add complexity, I think is probably the best thing to do at this point. I think that, certainly it sounds like with the EMSK derivation thingy, that's pretty straightforward. I wasn't clear on the compound MAC. It's a little more complicated because there's more of a security issue there.
Yeah,
Yeah.
so the underlying issue is you have the MSK, the EMSK, there you derive various acronyms from them.
Yeah.
Um, then you use that to put data into the crypto binding TLV. This works if you have one EMSK, one MSK, but the second round, whether you mix those or whether you have separate derivations, everyone did something different.
Okay.
So the first round's okay because there's no mixing, there's no previous dependencies. The second round, you could do it A, B, C, D, E ways, and none of those are compatible because the original spec was sort of helpful. Do stuff.
Yeah. So, yeah, I mean, I think we'd probably have to go talk a little bit more about that. But and in the security issue there, you still gain some level of compound binding, right? It just doesn't go all the way
Yeah.
to through the radius chain, right?
Well, it's the intertunnel data versus the TLS session. So TTLS, for example, I was looking this morning and I posted a message to the list. TTLS will derive the CHAP challenges and the MS CHAP challenges from the TLS PRF.
Right.
So those are tied to the tunnel, but not for EAP TLS. So TTLS has exactly the same issue with lacking crypto binding if you run EAP TLS or other methods on the inner method. I mean, arguably this is shipping. We should document what's shipping and go, yep, it's insecure, and then fix it later.
The problem is you have it's not just that you don't have EMSK crypto binding after the first one, you have no crypto binding because they don't
no
interrupt.
crypto binding.
Okay. Yeah. Yeah. Yeah, we need to have more discussion. But
yeah. So this is perhaps an option to double check that. Is something I hadn't thought of before going through all this complexity, right? The current document says for basic passwords, you use an MSK of 0, and too bad you don't have crypto binding.
Yeah, well, you can't really.
Well, it wouldn't hurt to do something like TTLS then, right? You derive an MSK from the outer TLS PRF, but we would have to rev TEEP for that.
You're still not going to really get any binding, I don't think, because I mean, if it's just basic password, it's just a basic password. There's no.
What I'm saying is, the current document says because the basic password doesn't derive an MSK, you use an MSK of all zeros.
Yeah.
But you could derive something from the outer TLS PRF, and that would address the issue, which now you have no binding for basic password.
Right, but I don't know that the binding does anything for basic password.
It means you can tell if there's someone in the middle mangling things. I don't
think it does in the way that you think it does, or in the way that crypto binding is intended to work, right? Crypto binding works because you have two keys, right? Yeah. The outer key and the inner key. Basic password, you don't have, there's no inner key. That's why we have to go through this thing. So but the net thing though is that I think if we can simplify it by saying, if implementations don't chain methods together, or they chain a very specific set number of methods, we can fix that and say this is the way it works now, and then decide, because the original spec had too many options, obviously.
Too many options. So I've tried to discuss how to do this multiple MSK, EMSK derivation in the current document. the feedback has been it's still unclear. I think it's a lot more detailed than the previous text, but it is a very complicated derivation. And if we're going to do this, it may be worth just stripping it all out and going, it's only MSK with EAP TLS as the inner method. So all that text becomes a lot easier. Then when we do TEAP v2, we can define a method which is easier for people to understand, right? Because if nobody understands the text in the document, it's wrong. If we define something fairly simple, then it's a lot easier.
Yeah, or we just, yeah. I mean, I think we'll have, with the implementation, you'll have a better chance of getting something that works.
So,
yeah. And then the last one was just chaining in general.
yeah.
Yeah. If we can, it would be good to move relatively quick on this if we can. And if we can figure out like, oh, this is the chaining options we should support, and then drive the MSK and EMSK from that, sounds like it might be a good idea.
So if we get consensus to, I'll go back some slides. So if we get consensus to do MS Chap internally, or MS Chap followed by MS Chap, or EAP TLS, or EAP TLS followed by MS Chap, that mostly works. If everyone agrees to that, we write down, this is TEAP v1, this is what's known to work. I delete half the text in this EMSK compound MAC derivation, and it becomes a lot easier to understand. And then the shipping implementations are all compatible. Modulo Microsoft not checking the EMSK, but the implementations are then all compatible, and they will all work, and no one gets their product defined to be non-compatible or non-compliant.
All right, and so let me ask our AD a question. So we're proposing, I won't say radical surgery, but a lot of stuff in 7170 bis is going to get chopped out, and then a little bit of rephrasing around some of the other text. What do you see as the process for doing that, given where the document is so far? Is it coming back to the working group because of the amount of...
Sorry, is this a document you gave me recently, or?
Yeah.
Okay, sorry.
Yeah, I mean, yeah.
It's in the RFC editor queue, and it's broken enough that we will have to change pages of text.
Okay, and then just let's put it back in the working group.
Okay, thanks.
Okay.
Anyone else? I see no one in the queue, but does anyone else want to offer an opinion?
Yeah. If we can get feedback and consensus, I'd like to get the document out as quickly as possible, because it's been this albatross around my neck for a little bit. Yeah.
Fair enough. All right. Thank you, Alan. All right. Next up, we have EAP ad hoc. Good. All right. You'll pass that through.
Hello, can you hear me?
Yes, we can. We're just passing you control for the slides.
Okay, thank you. So, in this presentation, basically, we are giving a quick recap of what have we been doing with the last updated version of the draft. Basically, just a quick reminder, we are proposing the implementation of a EAP method called EAP ad hoc, which leverages ad hoc as authentication mechanism as a very lightweight authentication mechanism for EAP. We can also leverage different kinds of credentials, basically all type of credential for which COSE has a head parameter defined. And we have addressed other reviewers' comments so far from Gabriel Lopez Millán, Francisco Lopez Gomez, and Josh Howlett. And just to mention that Francisco is from now on also a co-author of the work, so welcome. And yeah, basically we have updated some parts of the document which were still missing. Basically, regarding the key hierarchy, we didn't define previously what the peer ID and the server ID parameters that need to be exported by the method were. And in this case, we are assigning ID credential for the initiator and the responder respectively, which are defined in EAP ad hoc to be the ones that are used to identify the credentials of the initiator and the responder. Okay. Regarding the section of security considerations, we have been doing there some intense work, trying to have the document as ready as possible. And basically, we have done this table, which is the one that the EAP standard asks us to do. And we have explicitly said for each of the parameters if the EAP method has a way of providing said security claims or not. So basically, all most, not to say all, the security claims that we are actually confirming is thanks to the innate properties of the ad hoc protocol, like the authentication principle based on all the credentials supported, the service root negotiation, mutual authentication, so on. And we also added some couple of claims which are not typically in the original table, which are cryptographic strength and forward secrecy and identity protection. I have seen that some other methods add additional points to the table. For now, we have left that outside, but I don't see any issues putting everything together. This is just, I think, a way of presenting the claims. And now the two claims that I think are most interesting here, basically channel binding. We are checking yes in this aspect. So based on the external authentication data, the EAD, which allows ad hoc to process external authentication authorization data by providing mechanisms to transport this information. Ad hoc provides us ways of transporting this on every message, but because on the RFC says that the channel binding has to be transported after key material has been derived, what we are proposing is using the EAD 3 and 4 that are the ones transported actually after this has happened. Okay, and we are proposing therefore a new EAD item specifically for this to be defined, and then we can transport the information for the channel binding. The other security claim that we have actually currently set to no, but it doesn't have to be because it's fast reconnect. So currently, of course, we don't support it, but we can do that if we take in consideration that there is currently a draft adopted by Lake, which is ad hoc PSK authentication, and we could leverage that to provide the fast reconnect feature. The issue here is that that's a dependency that, because it's a fairly new document, we understand that it will take some time to be standardized, okay? And what we are asking is basically what to do. So the proposal now would be not to include it now because this would block the work at this point, keep processing the document, and maybe update the specifications if later if this is something that we understand that is a feature that is asked for or required. Okay, and that's basically a question that I would like to ask to the working group. How should we proceed in a case like this? Is it preferable to provide everything beforehand, or maybe just wait and update the document later?
This is Joe. So I would say, I don't know, but it would kind of depend on the use cases and the property of your protocol. So it's an optimization, right? So if your full handshake or whatever is fairly quick, then maybe doesn't take up many resources, is probably ad hoc is kind of geared that way. Maybe it's not so important, right? And the other thing is, what is the typical environment that it's used in? Is it likely that you're going to run into having to do a fast reconnect a lot for some particular, roaming or, moving from one place to another? Is that going to cause you to bounce around or something just because of the underlying technologies in use? It might be a worthwhile optimization, but I think it's kind of an optimization in my view. Speaking as a participant.
Okay, thank you. So we will take that into consideration and, well, ask amongst the co-authors how to handle it. Thank you very much. And yeah, I think after that, basically, we have a pretty good version of the document. I think it's mature enough, and we have just after taking into consideration the input from the working group, if there is something else here, well, we will do some internal
All right. I would suggest that you post to the net to mailing list and get more feedback, because I'm assuming most people haven't seen your slides since they're relatively fresh and may not be aware of the question you're asking.
Sure.
Okay.
Sorry about that.
Jan-Fred speaking. Given that I have an own EAP method that I'm defining and I've looked at a lot of stuff, what is your typical use case for this EAP method? Because so the question I'm actually asking is, are you using this EAP method for wireless authentication over wireless LAN? And if so, have you looked at RFC 4017, which defines some additional requirements for EAP methods that should be used over wireless LAN? I'm asking because I did an analysis on this RFC for my EAP method as well, and found at least one issue called shared state equivalence, which might need some consideration for my EAP method. So maybe you should also look into that.
Okay, thank you. So we will definitely review it for the input. So it is clear that the ad hoc is, of course, the focus is IoT environment. Okay, but as such, I think we may not want to discard any technology to be useful. So maybe we need to look into Wi-Fi as well. So thank you for that. We will have that into consideration and see if we need to add some notes to the next version of the draft. Thank you. And we will also post as Peter suggested to the mailing list to get some additional feedback. And according to that, well, we just generate the next version of the draft. So thank you very much. There is nothing else from our part. If there are any additional questions or comments, I'm finished. Thank you.
All right. Thanks very much, Dan. I don't see anybody in the queue. So, Jan-Fred, you are next up.
Okay. Let's see. Slides clicker. Okay. Yeah, a short update on EAP Fido. I will change the name. I promise soon. But it's coming. What happened since Dublin? Well, not very much, mainly work in the background due to such a thing called master's thesis. They take up a lot of time, a little bit more for me, but I can finally say it's finished. I submitted it and it is on EAP Fido. So I actually worked in the background on this, just hadn't time to update the draft. So I pushed a new version, which basically changes nothing, just to keep the draft or to get the draft out of the expired state. What happened at this IETF? So I still have my proof of concept. There is running code that implements most of the functionality in host APD and WPA supplicant. Host APD on the server side, WPA supplicant on the client side. And at the hackathon, Q sat next to me and said, I want this to succeed. I will write a server implementation in FreeRadius. Thank you, Q. We now have 2 server implementations. And it was very helpful because Q basically just implemented it based on the specification and not on my proof of concept implementation. So she had some valuable feedback, which basically was, well, the draft or the spec seems fine. It could definitely use a rewrite. I've noticed some ambiguous phrases where I definitely need to change the text because it's not exactly clear what I mean by that. But it looks like the spec is fine and can be implemented, which is a great feedback for me. We have still ongoing discussions or open discussions about some of the design decisions. So currently I use a custom Fido challenge format, which is a binary format because I don't like JSON. WebAuthn uses this JSON-like format. I mean, it's not really JSON, it just looks like JSON. And for my challenge format, I use the exported keying material from TLS to generate parts of the challenge, and the server can send additional challenges. In WebAuthn, the server always sends the challenge. So with this design, external Fido servers are not possible if they are implementing the way WebAuthn uses it, because in that case, the Fido server expects to provide or to generate the challenge themselves instead of the EAP server then telling the Fido server, hey, by the way, this is the challenge I exported from TLS. And for the Fido servers, also the challenge is expected to be, or the Fido client data is expected to be in this JSON structure. And of course, if I change the structure, then that wouldn't work and would require modification of the Fido servers. So there are pros and cons of the Fido challenge format. I won't go over everything in detail, but one important thing is we have no cryptographic binding if we use the Fido challenge generated by the server and not take the Fido challenge from the TLS keying material with a key derivation function. So that is something that we need to decide on. We have, in my opinion, a very good security in TLS by defining very good what server certificates, what trust anchors, what server name the client should expect. So we don't have the problem that we have in eduroam right now, or not right now, but we had in eduroam years ago, where people would just connect and set the client certificate check to do not validate and basically accepted all certificates. It's getting better now, but it's still a problem. Oh, that's the old slide version. Sorry. Yeah. So the other slide version, probably in the data tracker afterwards, that's what are the next steps. So I talked with the W3C security lead and told him a little bit about what I want to do with EAP FIDO. I have a name suggestion that I ran by him, and he seemed optimistic that that could work, that is a good name. And so now the next steps will be to talk to W3C about WebAuthn and EAP FIDO, how they integrate, maybe even ask the WebAuthn people if they can specify a... Yeah, let's see. That one, yeah. See if they can specify a general data, client data format that is protocol agnostic, so it's not fixed on WebAuthn. Maybe even add a registry so that if other protocols also want to use FIDO, they can register a label so that we don't get cross-protocol attacks. And the crypto agility is also still an interesting thing, because WebAuthn is fixed on SHA-2 to generate the client data hash from client data. That was an issue that was raised pretty early when I posted my first draft version. So one of the ideas that I had, because I really don't want to have a crypto algorithm negotiation in my protocol when I already have TLS, and crypto algorithm negotiation is hard, and I will make mistakes, and it's complicated. So my current idea is, can we reuse the hash algorithm that is negotiated together with the general cipher suite in TLS? In TLS, it's used, the hash is used for HMAC. So can we use that for traditional hashing as well? That's something that we need to think of. Yeah, and I think that's it. Thank you. Sorry.
I can maybe
Go
start
ahead,
right before.
Hannes.
So how do you want to get access to the negotiated hash? Because is that, can you, I haven't tried to get that out of the, you get, for example, a certificate that was, that's an API that implementations typically provide, but I don't recall whether the hash algorithm, because it's a kind of little detail, whether that is easy to get access to.
I looked at least at OpenSSL, and I think I have found a function. I have not implemented it, so
Okay.
I have no idea if that's even possible. But yeah, that's definitely a question.
The other
for
interesting
TLS.
challenge is you negotiate the hash, but then you also need to call the hash functions, which are like buried inside the TLS stack somewhere, which may not necessarily mean that you get access to them. So you maybe need to then populate your stack with the same hash functions that TLS stack has. But maybe it's not an issue, but.
Go ahead, John.
Yeah, yes, saying that typically you can get out the negotiated cipher suit, which includes the hash. Yeah.
But the cipher suite isn't like in TLS 1.3, right? This cipher suite, you could be negotiating something like AES GCM or Cha-Cha Poly 1305, and I'm not sure if the I guess maybe the key derivation hash is there.
Yeah, it's like AES GCM
Okay.
underscore SHA-256.
Yeah.
Whether you can negotiate something else, I don't.
So I think the current TLS, because I looked into it at least, and I think the current TLS specification mandates that each cipher suite has to have a hash algorithm that can be used for key derivation and HMAC. So especially for the key derivation function, that's where the hash is then used. So that's at least for current TLS versions, but I don't know if future TLS versions might change this procedure.
I don't know if Tirun Nokia, I don't remember there is a negotiation of hash algorithms, if my memory serves right.
Yeah, I think it's integrated in the general TLS handshake. So there is no dedicated negotiation of the hash algorithm. But if you negotiate a specific cipher suite, you have a hash algorithm associated with that cipher suite, and that hash algorithm is used for key derivation functions and HMAC if negotiated with the in the encryption and authentication part of the cipher suite.
If we level up a little bit more, one question to me was like, initially you wanted to start with the premise that, oh, we can use all the cool stuff from FIDO. And as you are making these changes, like creating these, changing the hash algorithm, changing the way how the challenge is done, changing the format from JSON to binary, because JSON is bigger and so on. There you ask the initial promise, and I wonder whether that's if you do that, if you go down that path, of course you can easily define something that is better than the FIDO spec. The FIDO design has all sorts of limitations which were imposed by the way how browsers work, but you are not bound to those limitations. So I think you are at an interesting point where you can decide how far you want to go. But once you take the path of, oh, I want to modify the FIDO and don't rely on existing stuff anymore, you obviously have tons of options, but that comes at the price. And I think you are somehow in an odd place in the middle where you unfortunately don't get all the benefits, but get all the disadvantages, which is a place I wouldn't want to be in, to be honest.
Well, the question there is, what is the alternative? So the alternative would be, I use the JSON format and I use statically SHA-2 to generate the client data hash from client data. So I would not have crypto agility, at least on the hash algorithm. So if SHA-2 is suddenly discovered to be broken, I would have to issue a new version of FIDO. WebAuthn would also need to issue a new version of WebAuthn, so I could just wait for W3C to solve the problem and then just piggyback on their solution. Yeah,
that's exactly the decision that needs to be made.
Yeah,
exactly. So it depends what you want.
Yeah.
For the TOS, the hash, at least one hash function must be available, because for the handshake, you need the hash to do the transcript, and that hash is negotiated in the cipher suite. So it must be available for TOS to work. For the KDF and for the MAC confirmation, it depends on the implementation. You call the HMAC. Does that mean you have somewhere to call the hash function inside the HMAC? But anyway, from the transcript, you need to hash the transcript, and that hash is negotiated in the cipher suite. So it must be available.
Yeah, the question is whether or not the TLS library exposes a direct access to that hash function, or if it just does magic internally and you never see it.
Yeah, and I just want to point it out. Yeah, the hash function got to be available for TOS, but I don't know your implementation, whether or not your environment allows you to really call that library function or not.
Yeah, we need to check it, definitely. It's on my list of to-dos.
You you also had mentioned a couple of things earlier in your slides, like cross protocol attacks and things like that, that may or may not be mitigated. I think we definitely want to make sure things like that are mitigated, because and the checking of the server certificate is not like a guaranteed thing. So I think we ought to look pretty closely at that.
Yeah.
For what it's worth, FIDO assumes that you check the server certificate.
Yes.
Yeah. So in a standard TLS connection, that's a little bit more likely. I think
Very likely.
Yeah. Right. I think there's a fair number of EAP deployments in the past, like Fried mentioned, is that doesn't happen as robustly as we'd like, right? And the conventions for doing so are weaker over EAP than they are over TLS in terms of server name validation and things like that. That I don't know if are important here, but could be, right?
Yeah, I mean, this is one of the key pain points in my current work. And that's exactly what I try to solve here, because the trust anchor and the server name is derived from the FIDO relying party ID. So I have a secure default onto what I expect. So I use FIDO for web anyway. So I have to have the web trust anchors anyway. So I can use the same trust anchors that my browser uses for validation of the server certificate in EAP. And by not giving any room for specifications to, or for implementations to invent their own checking method, hopefully that solves the problem that we have with current EAP methods, that you have to have this immense configuration and you have to explain it to users, or you tell the user, download this app, click here, click here, click here. And then finally you have internet and people shout at you why they have to install an app to use Wi-Fi.
But I think you answered my earlier question, because I think a different way to phrase is, you're working on an EAP method that was inspired by FIDO, but is not FIDO anymore. Because FIDO, the protocol relies on specific sort of architectural assumptions and also protocol assumptions, which you don't seem to like. And that's perfectly fine. And as you make this transition, you can make other changes too. And I think just admitting that is probably extremely helpful for the reader as well. And you can make then the changes that you said that you want to make and be done.
Yeah, I think the main problem here is that the current environment, the FIDO 2 environment, is joined from FIDO Alliance and W3C. So a lot of spec in the CTAP 2. So the client to authenticator, how do I talk via USB to, for example, a YubiKey? That's in the CTAP standard, but the CTAP standard references normatively WebAuthn. So they are really closely linked. So one option would be to go to FIDO Alliance and W3C and ask them, hey, can you specify a framework where you can use the FIDO ecosystem outside of the web in a secure way, in a specified way? So definitely, my EAP method was inspired by WebAuthn, and I want to reuse all that, hopefully even with the same keys. So you have the same FIDO key for web authentication.
That's what I came to the mic for.
that you can also use for wireless authentication. And that's why it's so important to have a very clear distinction and no cross-protocol attacks and such.
Tim Cavalli, editor of WebAuthn and CTAP. So the challenge, right, the rules are in WebAuthn, right? Very few people implement CTAP. The rules of how the FIDO ecosystem work are WebAuthn. And that's why we call it generically FIDO 2 WebAuthn. Platforms implement passkeys by default. Passkeys are defined by the rules in WebAuthn. Passkeys that get created for a very specific use, which is interactive user authentication on the web and related apps, will not most likely be made available to other applications and use cases, right? Because you You can't say we have another protocol that operates with different rules and expect access to the same credentials. For example, I don't think you want users having to interactively authenticate to the network every time, and that would be a requirement.
Yeah, well, that's exactly what is interesting here. So CTAP 2 defines silent authentication.
Correct.
And it works.
Correct.
So why does it work with roaming authenticators with silent authentication, but not with platform authenticators?
Because platform authenticators, as an authenticator, are WebAuthn authenticators. They're not CTAP 2 authenticators.
I would argue this is a bug.
You are coming into the, this isn't a criticism. You're coming into the ecosystem with a different use case. And this is a very robust, well-developed and mature ecosystem doing exactly what it was built to do. And nothing else, right? And that's largely why it's pretty consistent, well implemented, widely available, and does exactly what it's supposed to do.
Yeah, and I have an issue with the nothing else part, because you have a scenario that's web only, and there is something before web. So you need,
But the FIDO Alliance can design or decide what they want to design their stuff for. They have no responsibility designing it for use cases they don't care. They don't do that for IoT either. They have a separate group that does IoT and does totally different things. They decide if you want to, and I think that's quite important, if you want to leverage that sort of existing, let's say the keys, the hardware security modules, I think it would be super important to actually talk to the FIDO Alliance and figure this out, because if they don't want that, that would be problematic, in my opinion.
Yeah, and it's like I said, you're operating in the I understand it's messy, W3C, FIDO. You're operating in the rules of WebAuthn, right? Like that WebAuthn is where these are defined, right? And I think there are one example, right? There are other use cases, not necessarily protocols, that use WebAuthn constructs. Apple's attestation format, for example, for app attest uses WebAuthn constructs, but it doesn't rely on going over WebAuthn APIs. And so you can pick and choose, but the minute you call this thing EAP WebAuthn, that's problematic because you're not following the rules of WebAuthn, right? And I know that just seems like a name, but it's really important, right? Like WebAuthn is a user interactive authentication method. The minimum bar is user presence, which means the user has to do something physically, right? And yes, that doesn't exist in CTAP because you can use platform level-y things like SSH that maybe you want to be silent, or other things that happen directly from the OS platform to an authenticator, but that's not exposed upstream into the app and the web platform by design, because silent authentication for apps on the web would be very problematic. So I think it's awesome to take something and build something new inspired by something else, but trying to push it into the ecosystem, I think is gonna be a problem. I speaking only for myself, I do not think you will ever get a platform to implement and say, this has access to all of your existing passkeys. I don't see that happening outside of Linux. And I just don't want yet another EAP only method on Linux. We finally got TEAP implemented in places. I used to work in networking, so that's the only reason I'm passionate about this. And I would hate to see another thing that only works on Linux. We've talked about this for years, right? In my opinion, passkeys have a role, and it's getting you provisioned with a certificate and using EAP-TLS.
But EAP-TLS doesn't work. You need a.
I understand. I'm not trying to get it, but that's there is a role for passkeys as passkeys, right? Like as FIDO2 WebAuthn in that context. I think trying to bridge those is the problem.
I think Hannes again. Oops, I jumped.
Yeah, hi. So maybe not really strict related, but what about the team said just now. But for example, the OAuth, right? It has, and I noticed that you were developing some part of that, like OAuth for the native apps. So can we think about that, this like EAP stuff, kind of a native app in terms for the WebAuthn and particularly maybe OAuth? In that sense, does it fall into the category of the native app?
I'm sorry, I didn't really get the question.
I think I can repeat it. So I think he's saying, is the network just a native app, just like a native app is in the context of WebAuthn? Absolutely, yeah. But you have to follow the rules of WebAuthn. That's my point.
Yeah, okay.
Right.
So I think the main takeaway here is the steps that I have on this slide: talk to W3C, talk to FIDO Alliance, and see if there is a way forward, either by looking if the WebAuthn standard can be amended to or extended to different use cases that would include mine, or if that's a no-go for the involved parties and I need to divert to my own method that uses some of the existing stuff, but not all of it.
Okay, Alex. Alex.
Maybe Alex has no opinion.
Hello. There we go. Let's try again. Let's try with mute off. Sorry about that. If the WebAuthn interactive part becomes a bit of a problem, and in the spirit of keeping Alan's albatross alive, we might want to resurrect the pack in TEEP, and then you would be almost provisioning something like a pack in TEEP, and then that would allow your authentications to last longer and longer. And we get to keep TEEP running longer, right? It's only a suggestion, as if that became, you need an interactive login every single time. Well, we use that for the first time, and then later on, you've got you're provisioning that device temporarily with a pack, so then it can continue re-authenticating in the background until maybe the next day or the day after.
Yeah, maybe worth looking into, but I have my reservations about that.
I mean, you need to then configure TEEP, right? It's like the whole point is to let's not configure anything. So it's, anyway.
All right, this is Alan. Yeah, as a bit of a background, I don't know if Tim knows all the full details. EAP is a disaster, right? Trying to configure on anything anywhere is a disaster. Nobody uses 802.1x. Anything to make this work better is good news. And then in terms of provisioning, yeah, I'm a huge fan of TEEP. It's great. The one question I have, and this is perhaps something for 7170 biz and not this, is, there are provisions for provisioning. There's nothing which says how to do it. And if you have some kind of unauthenticated TLS-based EAP connection between me and you, how do you do provisioning when it's unauthenticated? You have to do some kind of weird out of band, right? Some random person connects to your server and asks for a certificate. Who are they? Well, they're unauthenticated. Okay, I'll give them a certificate.
Yeah, free Wi-Fi.
So I think, again, stepping back a little bit, because it sounds like we work on a couple of DLS-based EAP method, but then in one presentation further, we say, oh, those don't really work because there's provisioning, the provisioning step. And so we make all sorts of changes. But I think the right way would be to actually now look at those problems and fix those problems. And I think the one reason is why these problems haven't been fixed is because the provisioning step was kind of, sounds like it's a little bit considered outside the scope. It somehow happens magically. And then like DFN and other people then create some proprietary implementations for certificate provisioning in a really bad way that I scratch my head when I use them, which I had to use when since I became a professor. And you want to like, are these guys completely out of their mind? And do something really, really bad. And that's where we are. And I think that would be, I see that as an opportunity to also do that work in the open and discuss it and find the best possible solution to make the EAP methods that we heavily rely on work well. So in that sense, thank you for actually bringing this up, because I remember your first presentation on this topic, and I think we should have already started working on this at that time.
Yeah, it's ongoing. So I think we have a lot of things to do, a lot of talking to people. I have to say again, sorry for dropping the ball for almost a year, but master's thesis and all stuff. But yeah, I'll definitely pick it up again.
So is this something, Tim, that you can kind of help us make connections and find a couple different paths maybe that we could go down and see if what we can work through in the working group?
Yeah,
that'd be awesome. Thank you.
Okay. Thank you very much for all your feedback. Very helpful.
All right. So next topic is going to be a discussion of the EAP PPT charter item that Joe's going to lead. Jan-Fred, I will direct you to look at the chat at 1340.
All right, so we haven't done an adoption call for EPPT yet, so this is a bit premature. And one question for Paul would be, I mean, typically our EMU charter is pretty tight, and we usually recharter to bring in new work like this is. So I think we want to do a recharter for this. Perfect. So I'm just going to go real quickly through this. It's pretty much some of this was already discussed on the list. What we plan to do is start an adoption call. I'd like to do the charter update question at the same time, so that if the adoption call succeeds, we've already bashed some of the charter edition, and then we can just move forward with this stuff and not have to. And if it fails, then I worked on this text for no reason. All right, so I don't know if you can read this, but it says something like, while some EAP methods can provide some privacy, there still can be a leakage of information as to which networks a particular user is accessing. Privacy pass protocols and tokens provide mechanisms to protect the user's privacy in this situation. Well, maybe that needs to be reworded a little bit, but the group will work on an EAP method that provides privacy by preventing a visited network or service from knowing or correlating the identity of a user, and for the identity provider of that user from tracking what networks or services a specific user is accessing. So I'll post this to the list, obviously, but if anybody had any comments on this now.
Would you say like privacy pass protocols and tokens, for example, because like they ultimately they are just a wrapper around some other privacy technique. So if someone comes along and uses a privacy, so is this specifically tailored just for that single draft that just uses privacy pass, or is that meant to be also inclusive to a method that uses other privacy technologies that are don't happen to be included in that wrapper of privacy pass?
I think ultimately it's going to be privacy pass, but we could cast it more general than that. I don't have a problem with that. Is that what you're getting at? Is that like, we could say something, there are privacy protocols that provide mechanisms to protect users' privacy in this situation, such as privacy pass.
Yeah. What I'm also wondering is like privacy pass is actually not just one specific thing. It's actually being extended, and people realize it had a very narrow scope at the beginning, but then people realized, oh, actually it's now not so practical, and it has a very limited way to convey one bit of information, and then they extended it to, oh, I can use add public metadata, I can do batching, I can do this and that. But it's specific to the container of privacy pass.
This is worded that way, yes, but it doesn't have.
But what's it intended to? That's the question.
That's what I was thinking of when I wrote it. But now that you mention it, it probably shouldn't be that way. All right. Any other comments? All right. And then this pretty much says the same thing. This just goes in a different part of the charter a little bit lower down as items that we're working on. And so it's saying, an EAP method. I'm just going to repeat the last sentence that I had from the other one because it's the same sentence. Maybe I'll be a little more creative when I put the adoption call together, or Peter may be more creative. And yeah, so if anybody has any additional comments, and then we have a April 2025, because hopefully we do an adoption call soon after this, and takes a couple weeks, and we'll see what happens. Does anybody have any comments while we're on the topic of EPPT? Does anybody have any comments on EPPT? Yeah.
Sorry, Paul speaking as AD. Is there already a draft on this? That
Yeah.
you're- Oh, okay. Because I was like, are you going to do a 0-0 in 1 month? And I'm not
No,
sure the
yeah.
ISG would see that as a viable thing.
It's already a 0-1, I think. So. Yeah. I wouldn't go that far, but there is a draft. So, okay, that's pretty much all I have. And at the same time, we may call some of the old things out of the charter and rework the milestones and stuff like that, but that'll go to the list.
As you make these charter changes, would it be reasonable to fold in some of the discussion we had a few minutes ago, like also work on the look at the provisioning side, or would that be premature and have just first some proposals and so on and so on, or how does the rechartering in this group work?
So we already have an item on provisioning.
Oh, okay.
I mean, take a look at the charter and see if that needs to be adjusted, but we already have one on provisioning,
I guess.
and we already have one for EPOThen, or whatever we call it. You know, I don't want to get into the naming discussion, but so take a look at it. You know, I think we might be covered, but I haven't looked at this specific text. I looked at it and I didn't look at it in this context. So.
What I considered fascinating about the privacy pass method was not so much the privacy aspects. It was more the idea that you could, or you have to use separate connections on an end device to actually get the tokens and then to use them. I think that was the revolutionary idea in that proposal, because that was not an assumption. At least that's my reading of it. And that's not something we had previously. And if we tie that up with the provisioning, like the idea that, for example, laptops, they have multiple different radio interfaces, and you use one to get the tokens and then the other one to use the tokens for network access, that's actually a pretty powerful change in the architecture. And that could be used quite a bit, right? It's also something that you see with IoT devices nowadays, like they have one interface for provisioning and the other one which they actually use for connectivity. So it's a little bit in that line. So I think it's also architectural change in the way how things work that I thought was interesting.
Yeah, I mean,
but maybe I'm reading more into that than it actually is.
Well, I think in order to get the privacy properties that you want, that the home provider doesn't know what network you're at, or the identity provider doesn't know what network you're at, you can't be. You have to split things up in some way so that the same entity doesn't get all the information. All right, I think that's all we have for this one.
All right. So next up, Tiru.
Yeah, thanks. Good afternoon, everyone. I'll talk about PQC and hybrid enhancements for EPK Prime. EPKFS has been recently standardized by IETF, right? It basically solves a problem where your long-term symmetric key has been compromised, and you're leveraging ECDHE for forward secrecy, and that would pretty much be broken when we have quantum computers, right? And how do you address that problem, right? You would have to migrate to start using PQC algorithms. So that's the scope of this document. So there are two ways to do that, right? Either you start with traditional, you're already leveraging ECDH, right? Either you move to a hybrid scheme which includes both the traditional plus PQ, or you just directly migrate to the PQC chem, right? So we have two documents which talk about hybrid scheme and the PQC chem, so that deployments which want a traditional and defense in depth strategy can start with the hybrid scheme, or else for compliance or other reasons, if you want to migrate to PQC chem, you can directly start doing that migration as well. So the first draft is talking about hybrid enhancements for EPKA. So we are pretty much leveraging HPE specification, which is widely deployed and used by several protocols, and we are basically leveraging that to basically enhance ECDH to use PQ, to use a hybrid scheme. So we have added few attributes to the EAP protocol, basically where the server sends the PQC chem keys, and then those are concatenated together, similar to any hybrid scheme, and then the client basically uses that to generate its own ECDH key pair and the ciphertext for the PQC chem, and that is sent back to the server so that both of them can derive the final hybrid shared secret. So the color text is basically talking that instead of the typical ECDH shared secret, it's now going to be derived from the encapsulated PKR, which includes both the PQ chem as well as the traditional one, so that you get the security properties of both the traditional and PQ algorithms. So that's the only change with regard to the derivation of the MKK hybrid, which is eventually used to derive MSK and EMSK. Yeah, so we have defined a bunch of attributes to basically carry these new public keys and ciphertext there. And then the hybrid scheme is being reflected in the AD KDF FS attribute. And then we have the PQ chem for EPKA, which is basically using pure PQ chem. The interfaces are quite different compared to what we have with traditional key generation and NCAPs and TCAPs. So in this case, it's going to be just sending the key pair, and then the client is going to generate this shared ciphertext and send it back to the server, and the server and the client would have the shared secrets derived. So the flow is quite simple. Instead of the previous one, there will be chem NCAPs, which will be used to derive the shared secret, and which will be used to derive the shared secret eventually. And the bunch of attributes to carry these attributes as well. And PQ chem could be, for instance, MLChem 768. We are looking for more comments and consider for working group adoption.
Great work. Definitely needed. So looks like you did the right thing.
Thanks.
I have the same support for this potential work item.
Thank you.
Heike, did you want to voice your comment? Or would you like me to read it? It's in the chat. Heike said, could you consider providing these updates to EAP, aka Prime in WPA supplicant? That could help getting others to implement it too. For example, EAP-PWD is now in Android after it was added to WPA supplicant.
I mean, I'm coming purely from 3GPP perspective, so I'm not familiar how it's going to be applicable. So we could take it on the mailing list.
Okay. All right.
Thank you.
All right. Thanks, Tiru.
I think we're at the end of our regularly scheduled agenda. Does anybody have any other topics they'd like to bring up? All right, then we are adjourned. Thank you. All right, what time have we got? 15 minutes already? That's not bad. That was good discussion. Cool. Yeah, we should talk about this. Yeah.